All right, so one more example of discontinuity. And so this is to hopefully put the definition and how you can use it to prove things. So we have a piecewise function here. So it's x squared for when x is less than 2. It's a for when x is equal to 2. And it's x plus 3 for x greater than 2. So the question is it possible to make f continuous everywhere? And so if we look at our graph of this piecewise, it's missing the x equals 2 here, right? So at x equals 2, we're going to have some a that we can place anywhere we want on here. So we could put it at 2, 1 right here, or so on. So it looks like this graphically. We have this a that's floating, so I can make my a 1.5, so it'd be 2, 1.5. But basically a is a variable, and so I can float it anywhere I want in here. And so I can fill in that hole, or I could fill in that hole. But I can't fill in both. And so if you think about this, the main definition for continuity, right, is do you have to pick up the pencil? So as I'm graphing this, do I have to pick up my pencil? Yes, no matter what, I can't fill in both. So if I only fill in one, I still have to pick up my pencil, which means this is discontinuity. We have a point of discontinuity. So it is discontinuous at x equals 2. And so our question is answered. Again, I have to come in here from the left, and then I have to pick up my pencil to continue. So that is a point of discontinuity. So is it possible to make f continuous just by filling in one dot? No, it's not. No matter where I place my dot, I can't fill in 2. So if I want to just fill that one in and say that it's 4 for x equals 2, that's great. It's still discontinuous. So is it possible to make f continuous? No. We have it is discontinuous at x equals 2. But just like everything, you can't just say, oh, it's discontinuous. You've got to actually have a reason for it. And so you remember our 3 rules that we use to show continuity. We can use them to show discontinuity as well. So number 1, f of a is defined. So does that one match? Yes. At x equals 2, we're going to get some number a. And so we're using a here, I know, but it's not the same a. So f of 2 is equal to a. So check. So we can't use that one. Number 2, the limit as x approaches a of f of x exists. That's the one we get to use. So if you look at this, we already know that what we're trying to show, this should be a 2 here, is that the limit as x approaches 2 of f of x is equal to what? That's what it's asking, right? And so if we show that it equals a number, it matches 2. But if it does not equal a number, it doesn't match. And we already know at 2, it's not going to. Look, coming in from the left and coming in from the right, they're approaching different numbers. So our limit from the left is 4, and the limit from the right is 5. So we just have to write these out. So let's start with the left. So the limit as x approaches 2 from the left of our f of x would equal, and then this one here is our left, and this one here is our right. And so coming in from the left, we're getting the x squared. And so we can now use our substitution, so that would be 4. And then coming in from the right is the other one. So coming in from the right of our f of x, that would be the limit as x approaches 2 from the right of x plus 3. And that becomes 5. And those are not the same. And so since they're not the same, therefore, the limit as x approaches 2 of f of x does not exist. That means this fails. And so by showing that the limit does not exist, you are showing that it is discontinuous. Therefore, f of x is discontinuous at x equals 2. So by showing that the limit does not exist, we show that it is discontinuous. Because coming in from the left and the right, they're not the same. So the only way this is going to fill it in is if these two connect, right? And so coming in from the left and the right, they match. Meaning our limit has to exist. So coming in from the left and the right, they have to meet the same point. And that's what number 2 comes from, that they have to exist. And then if that's the case, then that point, if you take number 1 and number 2, that dot has been filled in. they are connected. Number 1 and 2 is true, so number 3 has to be true. The limit as x approaches a of f of x is equal to f of a. And there you have it. Thank you.